Next, the production of cyclohexanone by the chromic acid oxidation of a secondary alcohol. Here again, primary alcohols oxidize easily through inorganic means to aldehydes, but then the process does not stop there. They go all the way to carboxylic acids. Secondary alcohols will oxidize to ketones, and then the process stops. It's actually quite difficult to further oxidize them to esters. So for today's lab, a secondary alcohol, specifically cyclohexanol, into a ketone, cyclohexanone. It is an oxidation step, even though the oxidation number of the carbon does not change. Okay? In organic chemistry, decreasing the amount of hydrogen or increasing the amount of oxygen attached to a carbon counts as oxidation. So going from an alkane to an alkene is an oxidation step. Going from the alcohol to the carbonyl in the ketone, you're increasing the number of bonds between the carbon from 1 to, and the oxygen from 1 to 2, so that is an oxidation. There are also elimination reactions in that we're using some of the electrons in the reagent to create the new pi bond. They are acid catalyzed. Okay. So here's the reaction that we're going to do. The mechanism on how the chromium and the sulfuric acid get together to do that is not well understood. But for the final, you should be able to take a secondary alcohol in the presence of dichromate and sulfuric acid and tell me that it's going to make a ketone.